Hello everyone, so today we are going to look at how to solve initial value problem using RK method. Okay, so the initial value problem that we are interested is y prime equals to negative y plus x. This is the initial problem. Now with the initial condition, you have initial value problem. So we know that this x here, this is my x naught and this is my y naught. Now this initial value problem can be solved using integrating factor. Okay, if you want to find the exact solution, is given by the exact solution is given by x minus 1 x minus 1 plus 1.8394 e to the power of negative x. Okay, this is my exact solution. Let me write it here, exact. Okay, I've solved this using another integrating factor approach. Now, if let's say I want to use using, now the question says, something like this: solve using explicit trapezoidal rule for h equals to 0.2 and n equals to 2. Now what this means? This means that we're going to look at only two steps. Okay, if I draw the diagram, okay, I'm just looking at x0, x1 and x2. So which is this is n equals to 1, n equals to 2. Now you know that for each step, my step size h equals to 0.2. Okay, for the first step, we know that the initial y naught is given by 3. But we don't know what is y1 and we don't know what is y2. But we know what is x1 because x1 equals to x0 plus h, which is negative 1 plus 0.2, which is negative 0.8. And x2 will be x1 plus h, which is negative 0.8 plus 0.2, which is negative 0.6. So when x2 equals to negative 0.6, what is y2? Okay, that's the thing we want to find out. So we want to find out the value of, obviously to find y2, you need to find y1 first. Now if you recall, you have the explicit trapezoidal rule given by this butcher tableau. Okay, so there's two stages here. You have y1, y2, together with your stage derivative f1, f2, and my b1, b2, c1, c2. Okay, so we know that to find this yn, so the equation is given like this: y1 equals to yn minus 1, while f1 will be f of xn minus 1 y1. Now y2 is given by yn minus 1 plus h is 1, so h f1, and f2 is given by f of xn minus 1. Now c2 is 1, and Lastly, my yn given by yn minus 1 plus half, which is h over 2 f1 plus h over 2 f2. Okay, so what does it mean here? It means that in order to find my y1, I need to use my internal stages, big Y, and y1. So I need the help of y1, y2 for n equals to 1. And then you will get y1. Now for n equals to 2, I need to find y1 and y2 as well, and then y2. Okay, I hope you get the idea here. Now let's solve this for n equals to 1. For n equals to 1, we have y1 equals to y0, which is 3. f1 equals to f of x0 y1, which is f of negative 1, 3. And putting into this equation, we have negative 3 minus 1, which is negative 4. Now, y2 is given by y0 plus h of f1, which is 3 plus 0.2, f1 is negative 4. So y2 is given by 2.2. Okay, continuing. Therefore, we can have my f2 now, which is given by f of x1, y2, f of negative 0.8. Now y2 is 2.2. So we have negative 2.2 minus 0.8, which is negative 3. Okay. Lastly, my yn is given by y1, and it's 1 y1 y0 plus h over 2 f1 plus h over 2 f2. So working on this one, my y1 is given by 3 plus 0.2 over 2, f1 is negative 4 plus h over 2 f2 is negative 3. This leaves me with 2.3. Okay, so this is for n equals to 1. Now similarly, I can find for n equals to 2. Now y1 here, big y1 is my previous value, y1. Okay, so what happened here, I have found this value, and I have obtained this value, y1, which is 2.3. Now with the help of this little y1, I need to find my y2, y1, y2, and my little y2. Okay, I hope that is clear. Now let's just continue. So this is equals to 2.3. Okay, and then we have f1. f1 will be f of x1, y1, which is f of my x1 is negative 0.8. Now y1 is 2.3. See, negative 2.3 minus 0.8, that will give me negative 3.1. Now y2 is given by y1 plus h of f1, which is 2.3 plus 0.2 negative 3.1. That give you with negative 1.68. Sorry, it's positive 1.68. So I can find my f2 now, which is f of x2 big Y2. F of negative 0.6, 1.68. Negative 1.68 minus 0.6. That gives you negative 2.28. Lastly, my little y is given by y1 plus h over 2 f1 plus h over 2 f2. This will be 2.3 plus 0.2 over 2. f1 is negative 3.1 plus 0.2 over 2. f2 is negative 2.28. Okay, computing this value now gives you 1.762. So we have obtained the approximation at this value at x2 equals to 0.6. My y2 is given by 1.762. Now, is this a good solution? We don't know, so we have to compute the error. So the error we have obtained earlier on. Now let's check the error. Okay, earlier on we have obtained the error as the z. Okay, to find the error is given by az minus approximation. Approximation is also mean your numerical value. Okay, so exact solution that you have computed earlier on, yx equals to x minus 1 plus 1 plus 1.8394 exponent negative x. Now we obtain x. If you look at there, our x2, my x2 is negative 0.6. So for y negative 0.6, you have negative 0.6 minus 1 plus 1.8394 exponent negative 6. So what this value gives you? So this gives me 1.7516. Okay, so this is the exact solution. Now the approximate solution that we have computed or your numerical solution at x equals to negative 0.6 is given by 1.762. So therefore, your error is given by 1.7516 minus 1.762, which is 0.01039 whatever, which is good, small enough. Now assume this is RK method of order 2. Okay, explicit trapezoidal rule is of order 2. Now if you use higher order method like 3-stage method, the error for 2 iteration will be much smaller. Okay, so this is how you solve initial value problem using Numerical method. Bye.